Everywhere around here, you can see there's efflorescence, this like white calcium buildup on the wall. All right, guys, so I'm back with another DIY how-to type of property repair video. And today we're going to be talking about how to do your own basement waterproofing system and foundation stabilization, because those are two problems that are commonly associated with each other. So first things first, let me just lay out the situation here. About 1 month ago, we purchased this home as a rental property. It had serious water intrusion issues, and also all four walls were bowing. This wall over here was bowing 2 inches, meaning doing this inwards. This wall was bowing about 1.5 inches and tipping in about 1 inch. That wall was bowing about bowing about 1 inch, tipping about 1/2 inch. And this wall back here was just tipping in about 1/2 inch. Every single wall had signs of water intrusion, calcium built up on the wall. All the floor tiles which were in here were all popping up and falling apart. That was a fun job to deal with to even start the project. But anyway, I'm guessing you clicked on this video because you have a wet basement or bowing cracked walls. Then you want to figure out how to solve it yourself and not pay a company, $30 or $50 or $60,000 to do it. So just as a spoiler, I'm going to go and tell you, I spent $6,000 in materials to permanently waterproof and stabilize the walls in this basement. $1,000 on tools, and I spent 20 days of labor doing this all by myself, and I think it was worth it to save myself about, on average, $40,000. So just as some credentials about myself, I've worked in property damage remediation for since 2016. It's 2023 now. Not all of that was full-time. I was a college student for 3 years, and the last year of that, I worked for the biggest foundation company in the world, where I was a project estimator, where I'd go out and I would design these systems and bid them every single day for about a year straight until I quit about 2 months ago when I bought this property so I could work on this and resume my real estate business. So anyway, yeah, so if you're looking to save, so that's my credentials. As an estimator, I would have bid about $60,000 for this project. And then give them a discount, and probably would have been about $55,000 in total. A cheaper company might have been about $35,000 or $45,000 to do it. And just a quick summary of what it is. I've got 27 I-beams here. This is an 1,150 square foot basement. That wall's 48 feet and this is 24 feet. All right, just a rectangle. I got 2 sump pits, about 140 linear feet of drain tile, and every wall has plastic on it tucked in behind my dimple board going into my drainage tile, which runs to my sump pits. All right, so this is going to be a guide on how you can do this yourself. I'll be playing clips of myself doing the work and kind of talking over those clips to explain what I'm doing, what details I'm hitting, why I'm hitting them, what materials I'm using, and why I'm using them. A quick cutaway of what we're going to be talking about. I got my block wall right here. Weep holes drilled in it to let the water back through. I had the slab broken out, dug out the soil, put in a drain tile, or exposed the dirt down there by the footer, put in drainage fabric. That was actually double punched, non-woven drainage fabric, the good stuff, okay? You can't use that garbage from Home Depot or Lowe's. You got to buy it online, all right? Drainage tile in there, covered with drainage stone. Dimple board wraps all the way around it and allows water to come in and go into that drainage tile and then flow to a sump pit. Then I pour the slab back on top, as you can see that new concrete there. Everywhere where I had an I-beam in the bottom, I broke the footer out like this to make a deep pocket in the footer for the I-beam to sit in, and then smashed the I-beam down on top of the dimple board, braced it to the joists like that, and then poured the concrete back, or then pre-stressed the I-beam up against the wall, so it was really holding the wall up and had a little bit of pre-tension on the I-beam, or pre-stress on the I-beam, and then poured the concrete back around it to hold it in place forever. All right, so just as an example, go over here for example. Got a 6-foot level here on the top of the I-beam down there. You can see see that gap down there? You can see that I stressed this I-beam about maybe 1 inch in total. Every single one of these I-beams I bent in. That way I had a lot of contact with the wall. So that's the way I did it. I think this is the most robust system, so long as you hit every detail that I hit, and I'll explain every detail as I'm going through the video. So if you watch this all the way through, you should be able to save yourself, $30,000 to $50,000 on foundation repair and waterproofing, and never ever have to worry about your foundation walls bowing in or caving in, or having water issues in your basement ever again. Alright guys, so we've rewinded time. I'm back at the beginning of the project, and the very first step is to remove all the obstructions in the way of doing the job. And in this basement, I've got to remove sections of the ceiling to expose the joist bays to put my beam blocking in between every anchor location, or about every 6 feet. Your beam spacing depends on the height of your wall and the height of the backfill or the grade behind the wall. In my case, my wall is 7'6", and my grade is about 6'6" up the wall behind it. Plus I've already got the wall anchors, which were installed in 2007. They're grip type wall anchors, which have already been shown to be failing a little bit because I've already seen new cracks in the wall. Regardless, if your wall's like 8 foot with 8 foot backfill, you probably should have your beams every 3 foot. And if it's like 8 foot wall with 4 foot backfill, you should probably have your beams every 6 feet or so. Alright, so in this clip I'm showing you that third joist back is a double joist, and that I've only opened up a couple of joist bays there on the end walls. And in reality, on your basement, you should probably open up 5 or 6 joist bays back and put blocking between 5 or 6 joist bays to distribute the load of the beam across a larger section of the floor. In my case, I've already got wall anchors that are kind of doing their job. Plus, that paneling there is glued and nailed to the bottom of every joist, which will help distribute the load. Plus, my bowing is relatively minor on the end walls anyway. Alright, so now that I've got all the obstructions out of the way, time to get rid of the concrete around the whole perimeter, to expose that footer and see what we're working with as far as footer depth and footer size and everything else.
Alright, so I've broken out a little bit of my slab, exposed my footer, and figured out the depth of the slab and the footer and everything else. So I want to pause for a second and just discuss this, the significance of what I've learned. So the very first thing I noticed was, hey, there's tree roots underneath my slab. And where do tree roots grow? Where there's water, okay? So that's interesting. But anyway, moving on. My slab here, that's the floor slab, that's the bottom block of the wall, that's the footer, and I've undermined the floor slab a little bit, and I've undermined the footer a little bit to make sure I'm at the bottom of both. The floor slab itself is roughly 4 inches thick. The footer, to the bottom of the footer to the top, is about 10 inches, but the floor was poured to about right here on the footer, wrapping up and over it. So where the floor is on top of the footer is only about 1.5 inches or so, maybe 1 5/8 inches thick. So basically everywhere that I'm going to put a beam, I'm going to have to cut a section of the footer, or break a section of the footer out, because I want to have about 4 inches of concrete supporting the bottom of each beam. And I think that's thick enough though to put my dimple board down the wall. Another note is I don't want to put my drainage tile any lower than maybe a couple inches from the bottom of the footer, because I don't want to have water washing out underneath the footer, creating foundation settlement issues in the future. So I only have a little bit of room to work with here. My drainage tile basically has to sit at the bottom of this level, or at this level right here. And I got to pull my slab to this level right here. So it's going to be a tight fit on this particular basement for the drainage, and a little extra work for breaking out every section where one of my beams goes of the footer to get more concrete behind it. Hope that makes sense. Thank you very much.
Alright, so now I'm continuing to break this slab out. It took a total of 2 days to break the slab out. I'm using this Harbor Freight jackhammer here, and I'm pretty impressed with it. After you figure out the technique, it goes pretty fast.
The bit started out really sharp, brand new, and now it's really rounded.
It's absolutely important to sharpen the heck out of your bit every time it gets dull. What I found best was to make one side kind of flat and make one side more curved like that, and then put the curved side or put the flat side towards you and the curved side uh, in the area where you're trying to push the concrete out. It'll help break the concrete in the right direction. Alright, so there's the last 2 feet of concrete that I got to break out. This video is sped up to 8 times speed. Right now I'm at about 2 days of work into breaking the concrete out. Alright, so this here is the worst part of the whole job. I spent 2 days breaking the concrete out. That wasn't too bad. And then now I spent 3 full days, and a couple of them were long days, carrying the concrete out bucket by bucket, up the stairs, and then dumping them into my truck bed or trailer bed, and then taking them and dumping them on a friend's property that wanted the breakout for his stream bank. I think that if your basement is more than 500 square feet, it will be absolutely worth it to figure out a way to build a conveyor system and go out a window, or literally break a new hole in the top of the wall and put your conveyor out the hole in the top of the wall, going right into a truck bed or trailer. It will save you so many. I mean, this is probably 600 or 700 trips up and down stairs with buckets.
Alright, so I've got all the dirt removed from the trench and all the breakout and dirt carried out in buckets and hauled away, for the most part anyway, besides the sump pump locations. So now what I'm going through and doing is I'm breaking out the footer a couple inches down everywhere where one of my I-beams is going to go in. That way I've got enough concrete behind it in this area to hold the bottom of that beam in. I want there to be at least like 3 or 4 inches of concrete behind this I-beam, holding it in. Now don't worry, I know that I'm breaking the footer, but I'm not breaking all the way through the footer. I'm not cracking the footer. I'm just chipping out a little section every 5 feet, or every so often. I'm not actually like splitting the footer in half, okay? Plus I'm putting the concrete back and foundation repair anyway,
So I've got to break my footer out in pockets like this to fit my beams in to get adequate concrete behind them for support. In your situation, you might not be so unlucky. Most houses are built where their slab actually just completely sits on top of the footer level instead of being like wrapped around it like mine. So you may not have to go through all this crud that I'm doing, or you might break out your slab and figure out that your situation's even worse than mine, or you have no footer. You never know until you do it. Alright, so right here I've got my hammer drill in chipping mode, and I'm just cleaning up the top of the footer, all those little chunks of concrete slab that are still halfway adhered to it. This way my dimple board has maximum depth of concrete on top of it when I put it back. Alright, so now that my footer is prepped, I'm ready for beams. It's time to dig out the sump pit locations and prep the sump pits. Right here, yeah, you can see I'm taking it with a level, making sure it's slightly below the level of the slab. That's my sewage ejection pit. You probably won't need a sewage ejection pit unless you plan on putting a bathroom down there or a washing machine or whatever. And I'm just weighing down the sewage ejection pit with extra stuff, you know, a bucket of paint and rocks and stuff like that. That way it doesn't move after I put the soil back around it. And I'm just going to put soil back around this sewage ejection pit because it doesn't have any weep holes in it to collect any groundwater. So just put this dirt back around it. It'll save you some trips with the bucket. Alright, so it's now time to drill the weep holes in every block cavity of the wall and every mortar joint to ensure that any water that gets in the wall can drain out of it.
If you can't find a hollow spot, you just got to keep drilling higher and higher. This is the joint between 2 blocks, and it must just be full of mortar. You try to get the holes as low as you can. All right, guys, and one last note about weep hole drilling. I've got 3-core block. You might have 2-core block, or you might have something else. So, what I had to do is, because my 3-core block, the ends are concave like this, I effectively have a column of water there, there, and so on. So I have to drill a hole in every single empty hollow core of this block and the mortar joints. And then in areas where the mortar joints were completely full of mortar, I had to go above the mortar joint to the next block up and drill a weep hole there. And then in the areas where, like this one right here, I just had to keep on climbing until my drill bit sunk through into the core of the block, because the bottom of that block right there is full of mortar. So no matter what, make sure you get a weep hole that will drain in every single core of your wall. And make sure that you don't miss your corners. They're usually the wettest spot in the whole basement because there's downspouts out there. Matter of fact, go ahead and drill a couple of holes in every column and every mortar joint in the corners. 1, 2, 3, mortar joint. 1, 2, 3, mortar joint. 1, 2, 3, mortar joint. 1, 2.
I included this video section to emphasize how important it is that you make sure every weep hole is drilled. Alright, so I'm almost done prepping everything. I decided to put these sump pumps in right now, or sump pits in right now. That way they just hold the shape of the hole and stop the dirt from collapsing in or and whatnot. And it just gets them out of my way so they're not kicking around the place anyway. Alright, so you guys probably noticed that I didn't drill any holes in the bottom 1 foot of this sump pit or the other one, and I did that for a reason. First things first, this sump pit is not going to float out of the ground, because it's going to be locked in with concrete on the top, 4 inches or so. Second off is, once I've done all the hard work with my trenches and drain tile and whatnot to get the water collected, captured, and brought over to here, I want to manage that water all the way until the end of the system, which is outside in the yard somewhere. I don't want to be collecting that water over here in the corner and allowing it to leach out, through the holes in the bottom of the sump pit into my soil, creating a high moisture zone over here in the corner, allowing for my footer to settle in this corner, causing settlement issues instead of just bowing issues. So I didn't drill any holes in the bottom because I want to make sure that I manage the water from the start to finish of the system, and I don't want to cause foundation settlement issues from extra soil moisture in this corner in the future. Hope that helps. If this was in a crawl space, then I would drill holes in the bottom and put gravel underneath it to prevent it from floating out, but that's not an issue when it's locked in with concrete. Alright, so it took me about 3 days to get all that broken out dirt and concrete out of the basement, and it took me about 1 day to get everything back into the basement because I opened this window up and just yeeted it into the basement. For the concrete, I just made this chute quick and hasty like, and just parked my truck out there and just threw bags of concrete down the chute, and it worked out pretty well. Only maybe 5 or 6 of them actually got busted. For the gravel, I made this chute. I ended up having to make it a little bit steeper because you'll see it gets built up, but I was able to get about 2.25 yards of gravel down it really quick. Alright, so it's time to start the actual install. Starting off with putting up the wall plastic to capture any of that vapor that happens to wick through the wall so it can condense on the plastic and then go back behind the dimple board. What I'm putting up here is 15 mil Stego Crawl wrap, the same stuff I used in my crawl space encapsulation video, and I'm securing it to the wall using a Tapcon pilot bit and those big washer head pole barn sheet metal screws, just putting those into the concrete. Alright guys, so I'm going to pause for a second on the work and talk about where I'm at in the project and how much materials I've got, and so on and so forth. So I've got all the plastic up on the walls. That's to catch any condensation that wicks through the walls so it can condense on this plastic, roll down, and then go back behind the dimple board where this plastic is going to get tucked in behind the dimple board. See how it's hanging just above the footer? That way that condensation from the block can get into the system. So anyway, so what I've got left to do now is grade the trenches. That way they're either level or slope back towards the sump pits. Then I've got to, grade the trenches, put in my drainage fabric, put in my drainage tile, put in my rock, put my dimple board back on top of that, install my beams, and then put the concrete back on top of everything and to lock in the beams and, put the floor back together. After that, I just got to plumb my sump pits out and put the sump pumps in, and I'll be done with the project. And then, of course, clean up. So now let me talk about how much stuff I've purchased to do my 1,150 square foot basement with 140 or so linear feet of perimeter drainage. All right, so I'll just start with drainage tile. I've got 200 linear feet of drainage tile. I only need 140 or so, okay? It's socked, corrugated, perforated 4-inch drainage tile. I've got enough dimple board to do the whole perimeter. I've got enough drainage fabric to do the whole perimeter. That's Amazon special 4-ounce non-woven punched drainage fabric. It's really good stuff. I was just testing it to see how well it drains and make sure it doesn't hold water. It doesn't. And then this right here doesn't either. That's what's going on in the sump pits in case I run out of that. So yeah, enough linear footage of that stuff that's going in the trench. And now let's talk about the stuff that matters, equally as much, I guess. So I've got 1.5 yards or so of number 8 drainage stone. Very clean, washed river gravel, okay? It's drainage gravel, I guess you could say. I think that's a technical term for it. Number 8. So the size here is between, I think, 1/4 and 1 inch. That's like big pea gravel. You don't want limestone unless that's the only choice. And if you do use limestone, you got to use a sock drainage tile for sure, because the little chips of limestone will clog up the perforations, the perforations on that drainage tile. Okay, so 1.5 yards of number 8 drainage stone, and then I've got 140 bags. I think that's 2 yards of Quickcrete here. This is high strength Quickcrete. It's 4,000 psi rated. 140 bags of 50 pound bags. I got the 50 pound bags because they're easy to handle, as you can see. And then what else? Yeah, that's about it. So just make sure that you've got the right amount of materials for your square footage and linear footage of drainage. And if you think about, you look at that giant pile of concrete there and you say, wow, it's way too much concrete. Maybe it is, maybe it isn't. Maybe you look at that pile there, maybe it is, maybe it isn't. But you got to remember, I took 6 truckloads of material out of these trenches in sump pit areas. I need to put that same volume of stuff back. So if I just look at this stuff, I got a truckload there, maybe 2 truckloads there, and a truckload amongst the drainage tile volume, and then maybe a truckload amongst the 3 sump pits, but I kind of doubt that. So I might actually end up being too little material to put back. But anyway, that's where I'm at right now. Let's go ahead and put some concentrated Roundup in these trenches and grade them out, and then start the actual install. All right, so right here I'm just using the hose to clean off the footer and the edge of the concrete. That way the soil's wet and I can do the compaction of the trenches a little better. Okay, so I'm using a shovel here to go along and make sure that the trench is slightly sloped towards the sump pits, and at a bare minimum at least level, because I don't have a lot of room to work with here.
Alright guys, so before I actually put down the fabric in my trench and around my sump pits, I wanted to test it out for drainage. So I've got my hose And on the right here, I've got double punched, non-woven geotextile drainage fabric for French drains. It's 4 ounce that I got off of Amazon, and it seems like pretty good quality stuff. And then right here on the left, I've got Preen landscaping fabric that's really thin. You can see daylight through it when I hold it up. And this is woven, that's non-woven. And as you can see right here, this is holding water like a tarp. Holy cow. But I got my hose out. I'm going to spray some water in here. And it's just draining. So that's the 4 ounce non-woven geotextile drainage fabric, and that's just suds. There's no water in there. It drained really quick. And then right here, I put that in there a minute ago. It's still full of water, so I'll just... That's basically not even draining. So I'm not going to use this. I'm going to...
Alright guys, so as I roll the drainage fabric out here and put it in the trench, let's pause for a second and just talk about why I'm using drainage fabric, why I'm using socked corrugated perforated drain tile instead of doing like a box system on top of the footer, or instead of doing non-socked corrugated drain tile, and just talk about, you know, my drainage situation here, because it's very important. So I'm using this 4 ounce non-woven geotextile drainage fabric in the bottom of this trench because I know that it will never be plugged. That's just been proven that this type of fabric will not get clogged with sediment over time. It'll also help slow down and mitigate the size of the tree roots that grow into this trench. There's really nothing you can do about the tree roots except for treat with glyphosate, which is why I'm wearing the respirator right now, because I just treated with that. And then just, you know, hope that the trench doesn't stay full of water all the time by doing the grading of the trench to prevent the tree roots from growing into a big ball in there. So anyway, use the drainage fabric to keep the soil from migrating into your drainage stone. If you just dump the drainage stone straight into the bottom of the trench without any fabric, you are shortening the life of your system. By adding drainage fabric, you are potentially giving it an indefinite life by keeping the soil particles separate from the stone, which is allowing a lot more, water to be able to reach your pipe. Okay. Then on top of that, I'm using the corrugated perforated drainage tile with the sock on it, just as an added layer of security. This system is a very low flow system. Okay, this water seeps up from the ground, seeps through the wall. It's not doing a super massive volume, and it's not moving very fast. Okay, so the sock is not going to hinder any kind of flow. And as a matter of fact, it's going to extend the life of the system and make sure that it has flow here in like 20 years instead of just getting clogged up with sediment. Every time that you've ever seen a video or you've ever seen a socked drain tile fail, it's probably because they didn't put any drainage fabric in the trench, maybe didn't even use any stone in the trench, and then the clay soil just was right up against the drainage fabric on the sock and clogged it immediately. I'm not allowing that to happen. This is a totally different install than that. Okay, so I'm just using that the drainage fabric or the socked drain tile as an added layer of security to make sure that that my rocks that are in the trench don't clog up the perforations in the drain tile. There's just really no downside to using the socked drain tile in this situation. You're keeping the soil away from it as it is. Another thing is, when I go to install this drain tile, I want it to sit on the very bottom of the trench and define the bottom of the trench. Okay, I want to make sure that the water is not flowing below the drain tile, and especially not below my drainage fabric, allowing there to be washout around the bottom of the footer. I want all the water that moves through this trench to be moving inside of my drainage tile if possible. This is why I'm not using PVC drain tile with the 2 rows of holes down the bottom of it. This drainage tile right here, the corrugated stuff, has slots 360 degrees around the pipe. Whereas the PVC only has the holes in the bottom, so you have to put a layer of rock in the bottom of the trench to allow the water to come up into the bottom of the pipe through the holes in the PVC. This allows for a space for water to flow below your pipe, causing washout around the level of your footer, which is not good. And also, using this corrugated drain tile, let's just say in 10 years, the bottom 2 rows or whatever get clogged with sediment because of whatever reason. Who cares? I've still got, 260 degrees of inlet holes for the water to come in through from the top and sides. So drainage or corrugated drain tile in this application with the perforations and the sock on it with the drainage fabric is the way to go. There's just no other way that is as robust as the way I'm doing it right now. Using a box system on top of the footer just won't work for me because I don't have enough room on top of my footer, and because I just don't really trust that system because of how thin the concrete is on top of it and how close your water zone is to the concrete slab. One more thing that this drainage fabric is doing is it's also just holding that soil back from being washed out and then pumped out into your yard by your sump pits. So by using the drainage fabric, you're preventing possible foundation settlement issues in the future by washing out the soil from underneath your foundation. Alright, so what I'm doing here, even though it's kind of poor lighting and you can't see, is I'm installing cleanouts in the corners that don't have sump pits. That way if in the future I need to snake this system out or something or run a bore scope down into it to see if there's an issue, I can access it from either the sump pits or from either of these corners, allowing me to have complete access of the whole system from every angle possible. You'll see a better shot of this clean out here in a minute with better lighting. Alright, so one thing I want to point out while I'm filling this trench up with gravel is I'm stepping on that corrugated drain tile and filling the gravel up over top of it to keep the drain tile from like floating out and floating up in the gravel, which would cause like a hump or a belly in the system. Alright, so what you're going to see me do here is I'm going to walk around on this gravel and compact it as best as possible. It's round so it doesn't compact very easily. But I took about 5 laps around it doing what I'm doing here to make sure that when I install my concrete it has a lower chance of cracking and settling. So right here I'm cutting my blocking at like 13 inches because my 2x6 joists are not spaced all that far apart, and that's the way I install them for the long walls, and that's the way I install the blocking between the joists for the short walls. Every single tripled up 2x6 blocking here gets glued and nailed together. I just want to make this super strong. I think the bottleneck in this system in terms of strength is actually my 2x6 joists, but there's nothing I can do about that other than just not pre-stress the heck out of the beams. So right here you can see I'm installing that blocking. I got the beam set in the pocket, installing my scabs on the joist right now, gluing, nailing, and lag bolting them to every single joist. That's going to give the top of the beam the support it needs. Alright, so I've got a little bit of a gap at the top of this and a lot of gap at the bottom. I'm going to close up the gap at the bottom. I'm not trying to get any correction of this wall, but I do want to pre-stress the beam and make sure it has a lot of contact with the wall. If I was trying to get correction out of the wall, I'd have broken out the mortar joint that was cracked, and because it had been tuck pointed in the past, I would have broken that out, and then I would have cinched that up to the top and then really bent the heck out of this beam. Alright, so right here I'm just uh, tightening the beam into place, which is pre-stressing the beam, making sure that it's got good contact with the wall from the bottom of the wall to the about the middle of the wall where the bowing starts. Alright. I got a piece of rebar holding that beam back. This is the scary part. Okay, it's held back in place. Okay, perfect. So I basically deflected that beam about an inch, okay? This wall's bowed probably an inch and 5/8 or so right here. I just pre-stressed it a little bit, that way it's holding back the bulk, bowing part of the wall. All right, so here's a beam fully installed. Starting at the top, I've got my scabs holding back the weight of the tripled up 2x6 right there. Got the beam resting against it. A little bit of a gap between the wall and the beam at the top. That narrows and narrows and narrows, and then finally the beam touches the wall about 3 blocks down, or about 2/3 of the way up the wall. And then from right there all the way down to the bottom, the beam is flush up against the wall, supporting the entire, bottom 2/3 of the wall. And then it's really crushed up against the wall right there from the jack. You can see where I slotted the footer, and you can see where the dimple board is bending around that slot. And I got my piece of rebar supporting it to the existing concrete pad, holding that beam in place. That way it's pre-stressed, constantly pushing back against the wall, flush up against the bottom, 2/3 of the wall, really supporting the load of that wall, but not so tight and so stressed up against the wall that it is, stressing out the joists and whatnot, because I'm not going to be able to get any correction out of this, because that mortar joint that was cracked has been tuck pointed and filled with mortar. All right. Only 25 more to do. And I don't think that I've mentioned it yet, but these are S4 by 7.7 pounds per linear foot, A36 steel structural beams that I got from a steel supplier in Indiana. Alright, finally got the last beam on this wall installed. It was really difficult to install because I had to use my hammer to break out the concrete slab a whole bunch to make it nice and flat, so my jack could sit against it and so my rebar could sit in a little pocket in it and whatnot. But, yep, I got it nice and flush from the bottom all the way until about right here, 3. Right here I'm using 5/8 rebar from Menards. This is about the minimum size of rebar that I think is acceptable for this job. I usually try to cut the end of the rebar a little bit at angle where it goes up against the beam and install it so that the rebar is pointing downwards towards the beam and upwards towards the concrete. That way, when I put the concrete back on top, it's got 2 inches of concrete on top and 2 inches on bottom, and it's supported well up against that slab in a little tiny pocket that I chipped with the back of my hammer into the slab. If you have to leave your beams just rebarred in like this, like overnight, without immediately putting concrete back over top of it, make sure that before you put concrete back down, you go around and inspect every single beam and make sure that it's still pressured up against the wall and that the rebar hasn't shifted out of the way and released the pressure from the beam. All right, so on that one, you just saw me install the rebar on. You noticed I left a little bit of a gap in the back here, maybe a 1/4 inch, but it starts contacting the wall about 1/3 of the way up the wall right here, and then contacts it all the way up until about 1/3 down the wall right here. And I just can't bend it any more than that. I mean, I can get the 12-ton out and bend the heck out of it, but like I said, I don't want to stress any beam way more than the other ones. And this part of the wall right here was bowing. This is the second worst spot in the whole basement. It was bowing about 1 3/4 inches, if I remember correctly. So that's about as good as I'm going to get it. Yeah, it's touching the wall. It's got enough contact area and enough pre-stress that I feel comfortable with it. All right, so right here I am putting in the blocking on the end walls, the ones that where the beam runs perpendicular to the joists. Like I said, I'm taking this 2 joist bays back to that double joist, and I'm shimming it as tight as possible. Once again, I'm kind of counting on the existing blocking between those joists and the plywood to distribute that load across more joists further back. To be honest with you, you should probably put your blocking 5 or 6 joist bays back. But in my case, you know, these walls were not that bowed to begin with. That plywood is nailed and glued to the bottom of every joist, and there's already existing blocking in every joist bay anyway, so I felt comfortable doing this. Not to mention, I've got the wall anchors already in place on this end wall right here. Whether or not they're actually doing their job, you know, they're at least helping a little bit. Also, one more note about the beam install is you can see the top of my beams. They're not really held in place from like left to right shifting because the stress on the beam is already thousands of pounds and the bottom is already encased in concrete. It's just not going to shift left or right on. All right, well, I've got all 27 beams in. The ones on the end I did like that, where I've got it blocked up to the 3rd joist back, and then it's a double joist, so I've got it shimmed between the 2. Every single one of them has rebar supporting it to the slab, keeping that beam nice and tight against the wall. There's a couple in here that are worse than others, like this one right here. But luckily this wall has very little bow to it, so the beam is actually sitting completely flat against the wall, pretty much all the way up and down, even with a little bit of the minor amount of pressure that rebar is putting on it. The rest are pretty good. So, like I said, I got 27 total beams in here. I ordered 30 just to keep it a round number. And then these 2 over here in the corner by the sump pits. Like I couldn't put a piece of rebar through the sump pit and then hold that beam back and put it through like 2 sump pits and hold that beam back. So this corner itself is not actually that bad. As you can see here, this beam is literally just sitting on the wall. And it is pretty much tight to the wall all the way down. Same with that one there. This corner is not very bad. So those are just going to be kind of emotional support beams until the wall, if it ever does start to bow in, then they will catch it and stop it from bowing in after, you know, a 1/16 of an inch or something. So those will just be there and not putting any crazy force on the wall unless it starts to bow. But yeah, all 27 beams are in. Now it's time to go ahead and clean up the dimple board a little bit. So cut off all the excess here so I can expose the edge of the slab. That way my new concrete touches the old concrete. And then also I'm going to take some short tap cons, and in the areas between the 2 beams that's all crinkled up like this, I'm going to tap con that dimple board down like that. That way the concrete completely wraps around the footer and holds back the wall and footer in a good way. So I'm going to tidy up the dimple board and then go home, and tomorrow is concrete day. All right, so it's concrete time. I've got all my dimple board trimmed up and cinched tightly against the footer and wall. That way my concrete can go in here and make a really nice bridge between the old slab and the footer and the old slab and the wall. Get, you know, a lot of contact surface between everything. So really nothing left to do but start breaking up in concrete bags, mixing them and pouring them. All right, so in this clip, I'm wetting down the broken edge of the old concrete to help with the bond to the new concrete. If you had some help doing the concrete pour, you could have the helper go ahead of you with some concrete bonding agent or some Portland cement slurry and paint it on the old edge to help with the bonds to prevent future cracking. Alright, so I'm using the Harbor Freight 3.5 cubic foot concrete mixer here. It holds two bags of 50-pound bags of concrete just fine. I'm making sure that I'm prioritizing concrete strength, so I'm mixing it pretty thick. I know the camera shot doesn't really show that, but this has very low slump to it. It's pretty hard to finish. But anyway, I also noticed after watching this clip why my flashlight was dead after the end of today. So right here I'm broom finishing the concrete after it has had maybe an hour or so, maybe an hour and a half to set up and get a little bit hard. I don't really care about the finish a whole lot on this, but what this broom is doing is helping break down that edge of cream where the transition is from the old slab to the new slab. Make it have a little bit better transition. You'll see that I take my trowel and I dab the concrete several times up against the old concrete until I can see that it kind of sticks to it. This will help create a good bond between the old and the new concrete. All right, so I just finished the concrete. I had 140 50-pound bags, and that's all I got left right there. It's about, I don't know, maybe 15 or so. Yeah, looks like about 16 bags left. So I used 120, what is that, 124 if my math is correct. For the next 3 days, I wet down the concrete twice a day to help the cure. Also, I kept this basement at about 60 degrees Fahrenheit. I just want this concrete to be as hard as possible. All right, guys, so I'm almost done with the project. As you can see, I've cleaned up the whole basement here after I did the concrete, and I just plumbed out my sump pits. We'll talk about some of the key details of that in a minute. And then we got to head outside and bury the discharge lines for that sump pit water. So I'm not going to go too crazy and talk about every detail of plumbing a sump pit. There's a million videos online about that. mostly what I wanted to show you in this whole video was just how to do the water management system and the foundation stabilization. But let's talk about a few key details of sump pit installs that you don't want to miss. All right. So the very first thing, we'll start at the bottom here. Go up. You got to have a weep hole drilled in to your pipe below your check valve to prevent airlock inside the pump. If the pit goes dry and then fills back up with water, that'll create a bubble in the bottom of your pump, which can burn your pump out. So drill a weep hole before your check valve. Use pressure fittings in your PVC because this is pressurized water. It's not just, gravity flow water, it's pressurized water. And then most importantly, take that water up and eject it into your yard. Do not eject any sump pit water into your main sewer system, and especially do not eject it into your septic system. I used to work for a company called PuroClean where we did water damage remediation, and I saw it happen a few times where we'd have like a 3 or 4 day massive thunderstorm, and then we'd get a couple calls for people who had houses that got flooded where their toilets and bathtubs overflowed because their septic system got overwhelmed with the volume of water that the sump pit put into it, and it ended up pressurizing all their drainage systems and bubbling out of the toilet and flooding their house. Okay, because think about it, 3 day thunderstorm, your walls are going to be draining water like crazy into your system, and also your septic leach field is going to be absolutely saturated and unable to drain any more water, and your water is going to have to go somewhere to relieve itself of that pressure from the sump pit, and it might go, into your bathtub or into your toilet and flood your home. So that's that. Also, just another note, use a GFCI on any sump pit because at some point in the future, you're going to reach your hand down in there in the water and test the float switch. And if there's a short in the pit and your breakers don't work very well, you'll electrocute yourself to death. All right, so do that. Now let's go outside and bury those discharge lines. So here's my method for cutting the sod and digging the trenches. I can dig a 15-foot trench in about, 20 minutes or so doing this method. Loosen up the soil, pull the sod back, and then take big shovelfuls out. Here I'm undermining the sidewalk. All right, so before I backfill this trench and cover up my discharge line forever, I want to go over how I did it because I think this is one of the most important part of the systems if you live in an area that has freezing temperatures. So we'll start at the top here. I connected a downspout into this. I know it doesn't look really pretty right now. I'll take off all that duct tape that's exposed above the soil level when I'm done, or I'll spray paint it black, either way. So I got the downspout connected here with a leaf guard, okay? That way leaves don't get into the system. I've got solid, not perforated, solid corrugated pipe, okay? It's all sloped downhill. That's probably like at least 1.5 foot a drop from here to there. But if you don't have a sloped yard, that's okay. We can talk about that here in a second. Anyway, so my gutter is going into the leaf guard, going into the solid pipe, going into a Y downhill, okay? Every single connection is screwed, okay? So we got 2 screws in the top of every connection. Okay. Those go through the fitting and into the pipe below. And then right here is very important. This is my sump pump discharge. So it comes in, goes into the corrugated pipe, and there's plenty of airspace around here so that air can come into the top of this pipe and not create an airlock situation where the pipes will stay full of water, okay? Just like how you put your finger on the top of a soda straw, you pick it up out of the cup, and it stays in the straw. You don't want that happening with your pipe. You want the water to flow all the way out and drain into the yard. That way you don't get this frozen up in the winter, because you're not going to bury this like 4 feet deep, below the frost line. That's just unreasonable. So, yep, you leave an air gap up here at the top. Screw every fitting. Make sure that this is nice and solid. Like I've got like a widener down there basically, and then the screws going through it. And then also to prevent roots, as you can see here, I'm in landscaping. I got roots everywhere. I had to chop through a whole bunch of big ones. you know, real big ones like that and like that, digging this trench. To prevent roots, wrap the heck out of every single fitting with tape. I ran out of it, but you're supposed to use this vinyl tape right here for corrugated pipe. I used that on about, you know, half of these before I ran out, and then I started just wrapping it all with duct tape like crazy. Just do whatever you can to prevent the roots from getting in there and make sure it's one solid system all the way through. So that's that. So that's up here. Screw everything, tape everything, use solid pipe. Don't let roots get in here. Went under the sidewalk, had a constant slope all the way downhill. Or if you had a flat yard, that sucks, but still the same thing. You got to get the water out away from your foundation somehow. So at the end of the pipe, here's the detail, all right? So I use this angle yard grate because I'm on the side of a hill, but you can use a flat one. The most important thing here is that you drill 1,000,000 holes in the bottom of the grate. Okay. And put it over top of about a foot or two of drainage stone below there. This is especially important if you have a flat yard with no grade. That way the water can come down the pipe. The bulk of the water can just eject out into the yard and flow downhill. And then any water that stays in the pipe and sits in there can drain through these holes in the bottom and go into your drainage stone and weep into the yard instead of filling the pipe up with water and causing a giant ice block in the winter. All right, that's very important. And then down here at this fitting, you don't really need to tape it all up. I mean, you have holes all over the place. So roots are gonna be a thing. Just make sure this is, or roots are something you have to think about where you put the end of this. So don't put it anywhere near any landscaping or trees, okay? Just put it in the middle of some grass, all right? So, or shoot it off the side of a stream bank, even better. But anyway, that's the way you do this to make sure you never have standing water in your pipe so it doesn't freeze up in the winter. And of course, I've got this top grate screwed with one screw as well. All right, make sure you hit every detail here or else you'll have a frozen pipe or you'll have roots all through it and your sump pump won't eject, all right? All right, guys, so the basement's all cleaned up. The sump pumps are plumbed and the discharges are done. The walls are stabilized and the basement should be dry forever. Ignore that puddle. That was from me testing the sump pit, okay? So I should never have to worry about my basement walls bowing in or tipping in ever again. And I should never have to worry about humidity or water issues in this basement ever again. I should be able to finish this out with a drywall and whatever flooring I want and not have to worry about it ever again, okay? So let's get into what everybody is wondering about now. What did I spend? How long did it take? So on and so forth. So as you can see right here on the whiteboard, and I'll show a screenshot of the Excel where I put all my receipt numbers on. So I spent just under $6,000 in materials. About $2,500 of that was my 30 I-beams. Of which I only installed 27, and $1,000 of that was tools. So $660 for a jackhammer and like $260 for a concrete mixer and then some other stuff. I spent 20 full days working on this project. And the worst part of it, I would say by far, was I think it was 2 or 3 days I spent jackhammering, and then the 3 days I spent hauling all of the breakout and dirt out. I took a total of 5 yards of material. That's 5 cubic yards, or 12,000 or 13,000 pounds of material out of this, and then I had to put all that back. That was the worst part of it. So yeah, I don't know if I've mentioned this yet or not, but I used to work for a foundation repair and waterproofing company, the biggest and best in Indiana, and well, we did our waterproofing and beams a little bit differently, but I think I did mine more robust than we used to, or than we did at that company. Regardless, I was an estimator for them, so I'd go and I would quote these jobs 2 or 3 times a day, every day for about 1 year that I worked there. And this job would have cost about $60,000 pre-discount, or about $55,000 after a discount. And the breakdown of that would have been about $30,000 in beams and about $25,000 or so in waterproofing, give or take $5,000 each one of those numbers. A major killer here would have been all the obstructions I had to remove to get these beams in place. I mean, I had to take down, remove, and replace all of the plumbing and electrical on this wall. There was radiators, there was just all kinds of garbage on this wall I had to take out. And I spent like 3 days doing that. So anyway, so if I went with the most expensive company to do all this work, 27 beams, 140 feet of drain tile, 2 sump pits, and the plastic on the walls, I probably would have spent somewhere between, on the high end, $55,000, and on the low end, with a cheap company that may or may not have a good warranty, or may not have installed this with a level of detail and workmanship that I would want. They might have, bid me something like $35,000. So I saved at least $30,000 and maybe up to $50,000 by doing this. Okay, I'm happy with how it turned out. In about 2 months, I should be able to paint this floor after this concrete is 100% dry and cured, and you should really never even notice the difference, other than the edge being a little bit more rough finish than the middle. So yeah, that's that. On your job, hopefully you get lucky and your your slab won't be like notched around the footer like that. Normally a slab just goes straight up to the wall, and you won't have to deal with notching out your footer and putting your I-beams in those little footer pockets and whatnot. Oh yeah, I was going to show you the clean out as well before I end this video off. So there's my clean outs. Yep, and there's the cap for it. All right, so every corner and every wall is accessible from 2 angles. You probably noticed I put in a new set of stairs here. I destroyed the old one. They were really rickety and garbage. But yeah, so that's that. Don't forget to comment, rate, and subscribe. And good luck on your foundation repair or waterproofing project.